Hey, Econ Kids. Today we're doing module 47, interpreting the price elasticity of demand. So we kind of know what elasticity is, and now we're going to say, well, how can we apply this elasticity? So as you can see over here underneath this graph, we have something like uh, a supply and demand curve, okay? But we're just looking at demand. In this case, demand is perfectly inelastic, okay? So what is that telling me? Well, it's telling me if my price increases from P1 to P2, my quantity does not change at all. And what is something that could look like that? A lot of times it's something like the classic example is insulin. Because if we raise the price up on insulin, you're still going to have to pay for it because you need it to live. In Green Bay, I would say classic example is Lambeau Field, right? The quantity down here would be 80,000 because that's how many seats are in the stadium. They jack up the price every year on tickets, and people still pay it because they would rather go to the Packer game than feed their family. So they jack up the price, right? But the demand is still perfectly inelastic. I have tickets. It took me like 30 years on the list to get tickets. Um, there's still 100,000 people on the list. I think my son is on the list right now. He's been on there for probably 18, 20 years. 20 years, I think. He's 20 today. And he's been on the list since he was born because I put him there. And I think he's still like 42,000 seats away from getting tickets. So jack up the price. Those people aren't giving it up. They're still going to keep paying, and that's the way it is. Especially because the Packers are awesome, and this year, you know, even more so. So as you look at it, that would be perfectly inelastic, right? Here is perfectly elastic, right? You get a good that's like this. The price here, the demand is here. Let's say your quantity is here, and as you look at this good, well, what happens if you raise it to P2? Quantity falls just straight to zero, right? Um, what is a good that would be like that? Probably like the dollar store good, right? You'd pay $1 for it. Awesome, you love it for $1. But if it's $1 you're like, pass. I think dollar menu at McDonald's would be good. Same thing, right? Like you might want that McChicken for $1, but if all of a sudden that McChicken was $1.01, you might be like, I could eat something else. So as you look at it, perfectly inelastic, perfectly elastic demand curves. Another thing to note is this one over here up on the top there, it'll tell you the price elasticity is 0. Over here, price elasticity is infinity. So you might just want to memorize those because every once in a while the AP will ask you some weird question, and it usually involves the weirdest thing they can do, right? And the weirdest thing they can do is make a perfectly inelastic or perfectly elastic type of a line. What are some determinants of elasticity? Here, number of substitutes, that is always a good one, right? Probably, I would even say the best one. When you look at number of substitutes, we're talking about something where if there's lots of good substitutes, it's going to look more like this, right? More elastic. The less substitutes, it's going to look more inelastic. So when you think about something like gasoline's a good one, right? Because there's not really good substitutes for gasoline, so it's going to probably be more on this inelastic side. If there were good substitutes, then it would look more like this, and there's not. That pencil example is pretty good for this, right? Lots of substitutes for a pencil. You can use a pen, a marker. So that's substitutes. Luxuries or necessities. When you're talking about a luxury or necessity, the more necessary an item is, the more inelastic it's going to look. That's your insulin example. The less necessary it is, the more elastic it looks. If you don't really need it, even when the price goes up, you're like, pass, I'll buy something else. Dealing with these, share of income spent, it's not the overall, like, your budget, like overall in that regard. Okay, so even something that might be relatively inexpensive, or like it might even seem expensive when you're buying it compared to what that item could be bought someplace else, maybe. But if it's not a big part of your budget, then it's going to look more inelastic. An example would be like a pack of gum. You can go to Costco, get a pack of gum, it might be 10 cents. You go to Quick Trip, get a pack of gum, it might be $1.80. Well, okay, it might be more expensive at the Quick Trip, but because it is a very small portion of your budget in overall regards to things, like $1.50 is, nothing really there. So it's going to be more inelastic. They can keep jamming up the price on you there at the Quick Trip. You're still going to buy the gum. Whereas even though it might be more expensive than if it was at a different place, a grocery store, etc., but it's not a very large portion of your income overall, right? The more chunk of your income, the more elastic it is. Think about like housing or something like that. You raise the price, be like, maybe I'll rent. The last one here is time. Time is an interesting one because the long run, remember, is not defined, and this is really the first time we're talking about it, so maybe it's not remember. The long run is not defined by time. It's defined as how long it takes you to change over all your variables. So when you think about the long run being elastic, if you have time to change over everything, then you have more of an elastic good. If you have no time to change over, then you're looking at more of an inelastic good. So if you think about gasoline and you need it today, right? Because you have no time to change over anything. You still have a car, lawnmower, things that need gas. You're going to look at this for gas. But if you have the opportunity to switch, go buy an electric car, go buy an electric mower, do something like that, they might look more like this, right? Whereas if the gas is more expensive, well, I changed. I don't use gas anymore. Everything's electric in my life. That's what long run means versus short run. The only other one that got added in on this one, and you can pause the video and read these if you want, but the only one that got changed or added to make splat is addicting products. Any sort of good that's addicting, drugs, alcohol, cigarettes, vape, like those kinds of things, all pretty much look like this. Because if you're addicted to it, even if they raise the price, you're still going to pay it, right? So if you think about someone who's consuming alcohol, something like that, if they jack up the price, you're like, you know what, still buying it because you're addicted to it. Maybe some people in my department, it's Diet Coke, no ice. Yeah, they're still going to buy it. Doesn't matter what the cost is. They just need it, right? Coffee could be like that. Starbucks, why do they get to charge you as much as they want? Because it's an addicting product. Last but not least, this is your total revenue test. All right. So the way you look at total revenue is you take the price times the quantity. Okay. So when you're dealing with price times quantity, all you're going to do is look at like on a graph, right? You're going to take whatever that price is. So if your price is 1, 2, 3, 4. Okay, and then I look at where my line is here, and let's say this is 5, 10, 15, 20. Okay, so 1 times 20 is 20. When I raise my price to $2, 2 times 15 is 30. Okay, so this is my total revenue. It's my price times my quantity. In this case, 1 times 20, 2 times 15 equals. So when I've raised my price over here, my total revenue increased. So if you look on the little chart there, when I raise my price and my total revenue increases, that means I'm looking at something like an inelastic demand. Okay, inelastic demand. So I know this region from this point to this point, this line segment from $1 to $2 is inelastic. Okay, so I could, make that go, oh, it's inelastic. But now, if I was going to go from, let's say, 3 to 4, so I'm looking at this line segment up here. Well, if I do the same thing, price times quantity equals total revenue. If my price at, let's say, $3 times 10 units equals $30, right? And 4 times 5 units equals $20. So now I did the same thing. I raised my price, but now what happened? Here, I lost total revenue. When I raised my price, I went from 30 to 20. So when I raise my price and I lose total revenue, I'm looking at an elastic demand. So this line segment up here is inelastic. So down here, I was inelastic. Up here, I was elastic. That's how total revenue test works. So you just keep doing, like moving those numbers around, and you'll be able to figure out what that line segment is by plugging them in. Now, if you notice here, 2 times 15 is 30, 3 times 10 is 30. That means I raised my price, right, from 2 to 3, but my total revenue stayed exactly the same. That means this line segment in here, that must be unit elastic, because when I raised my price, total revenue didn't change. So if you were a person who was doing this item or had this item for sale, you would definitely raise your price. If it was at $1, right, you'd raise it to $2. But as soon as you got up to that like $2 and to raise it to $3, it was indifferent. It didn't make a difference what you did. You were unit elastic. But then if you decided to go from 3 to 4 and jack up the price one more time, you wouldn't do that, because now all of a sudden you raising the price actually caused you to lose money in terms of total revenue. So that's how you use total revenue check to be able to test for elasticity. Pretty simple little thing there. And what we find too is on here, it would talk about like that price effect and quantity effect, which is what we did when we were talking about the beginning, right? As you raise the price, how much quantity do you lose? If you lower the price, how much quantity do you gain? That's going to be showing you that on the line and telling you the slope. And then if you look, all these lines always kind of look the same. Your lower prices on there are always going to be more inelastic. There's always going to be a break someplace in the line, and the top part's going to be elastic. That line on the graph that it shows you here, that line to me looks like the whole thing would be elastic. But if we measure out the prices in those lower regions from 1 to 2, 2 to 3, 3 to 4, etc., in there it actually measures out as an inelastic line. That's how it behaves. So people will pay more for this good if you're at those lower prices. But once it gets a little bit too high, then they stop buying. That would be the end of this mod. See you next time.